Welcome, my dear student. The today's topic is the relational operator. Now, in the VHDL language, we will maximum times use the VHDL relational operators. In the relational operators can also be applied to the one-dimensional array. And for the ordinary relational operators ordinary relational operators are equal to, not equals to, less than, greater than, less than or equal to, greater than or equal to, like that. And the array element can be of any discrete type. The two operands need not to be in the same length, so the long as they have the same element type. The equals and not equals operators are simple. If two array have the same length and the corresponding element are the pairwise equal, then the array are the equal. The not equals operator is simply the negations of the equal operator. The way of remaining operators work can be seen when they are applied to the string of characters, in which case they are compared according to the case sensitive dictionary ordering. To see how the dictionary comparison can be generalized to a one-dimensional array of other element type, let us consider the less than operator applied to the two array A and B. If both A and B have the length 0, A less than B is a false. If A has the length 0 and B has a non-zero length, then A less than B. Alternately, if both A and B have the non-zero length, then A less than B if A1 and B less than 1, or if A1 is equal to B1 and the rest of the A less than the rest of B. In the remaining case where A has non-zero length and B has the length 0, A less than B is false. Comparison using the other relational operator is performed analogously. If you apply less than operator to the big vector representing the binary coded number, if does not compare to numeric ordering. For example, consider the comparison B00100 less than B10. Since the first element of the left operand is 0 and the first element of the right operand is 1, and since 0 is less than 1, the result of the comparison is true. And like that we will perform any operations very easily. But if we interpret the vector are unsigned binary number and the left operand represent and the right operand represent 2, left operand represent the 8 and right operand represent the 2, then we could then expect the comparison to the yield false. The matching equality and inequality operators are used for comparing the bit or the standard logic operand. This operator can also be applied to the operand that they are a one-dimensional array of a bit or the standard logic element to yield a standard logic result. The operand must be the same type and having the same length. The operator corresponding element are compared using the scalar version of the operator and the result reduced using the logical and the direction operator. The not equals operator is compared similarly with the not operator applied to the reduce and the result. In that way, we will use maximum times the relational operator whenever you have to compare or when you have to differentiate any two terms properly in terms of VHDL language. We will use a relational operator at that time. So our next operator is maximum and minimum operation. Whenever we will use a maximum and minimum operation, that will be simply here defined by a certain example. But first of all, we will see the maximum and minimum operations can be applied to the array of a discrete type element and finding the corresponding minimum and maximum value. As we have some example, that is minimum some value b of 0001, b of 0110 is equals to b of 0001. We have to find out the minimum among these two terms. Whenever we are given a certain number of numbers and we have to find out the minimum or maximum of them, we will use the maximum or minimum and minimum operation. Like that, here the command is a minimum of what? Minimum between these two ones. So your answer is this one is minimum. And if suppose we have to find the maximum of this one, so whenever you have to find the maximum of this one, the maximum is this one. The maximum and minimum operation are also defined as a reduce operation. and of a one-dimensional array of a scalar type. The maximum function of this form returns the largest element in the array, and the minimum function returns the smallest element in the array. Again, the comparison are the performed using the predefined, that is less than operator are the element type. Thus, the maximum string, as we have seen, that maximum string of wxyz is equal to z. Minimum string between wxyz is w. Maximum time vector of between 10 nanosecond, 50 nanosecond, 20 nanosecond is a 15 nanosecond, and the minimum time vector between 10, 15 and 20 nanosecond is a 10 nanosecond. In that we will find out a minimum term or the maximum term between certain arrays. For a null array, the one with a no element, the maximum function returns the smallest value of the element type, and minimum function returns the largest value of the element type. That is the one of the important term. If suppose there is a null element, there is a no any array, no any data, at that condition it will give the reverse operations, or it will give the reverse result. Now another one is a concatenation operator. Now another operator that can be applied to the one-dimensional array is a concatenation operator, which is represented in terms of AND, small AND, which joins the two array values at the end to end. For example, when you apply two bit vectors, it produces a new bit vector and a length equal to the sum of the length of the two operands. Thus, b of 4 times 0 and a b of 4 times 1, which produces the 4 times 0 and 4 times 1. The concatenation operator can apply to the two operands, one of which is an array and another of which is a single scalar element. It can also be applied to the two scalar value to produce an array of a length 2. For example, we will see here the example that ABC is concatenation with the D. So then the resultant output is ABCD. When W is concatenation with XYZ, it forms the result WXYZ. When A concatenation with B, it forms the result AB. And like that way, we will use. So whenever you have to join or whenever you have to combine the two different operators, two different array, and then at that time we will use the concatenation operation. In that we will see the concatenation operation easily, and we can use it whenever you have to write the VHDL program. Thank you very much.